for attending the webinar today. As you know, today we are going to discuss about the new features of Midas Gen 2015, which is just released. So we are going to see which features has been implemented and how we can use those features, how those features will be useful for your project. During the webinar, if you have any question, please use the questions window. Then at the end of the session, I will answer for your questions. So let's see the new features now. If we see the release note of this version, you may be aware of the new features. There are many new features has been implemented, and some of them are very big changes comparing to the previous version of Gen. Starting from the pre and post processing feature, we have the new menu system, ribbon menu, and there is many useful features. We will see the one by one. Also, we can now support the 64-bit operating system for the analysis and also for the graphical display. So let's see the new features one by one. This is the previous version of Midas Gen interface we have used so far. Even though we have focused on the usability of the software, but some of the menu required many mouse clicking. But in the new version, this is the new version of Midas Gen. In order to provide more efficient way of modeling, we have newly arranged the menu system to ribbon menu. The icons are arranged according to the modeling and design process with intuitive and graphical icons. Also, dual tree menu is provided for simultaneous modeling. For example, when you use the certain dialog box here, you can see the works tree or group tree at the same time. So this will be also useful for the easier modeling. This ribbon menu system will reduce the number of mouse clicking by placing the frequently used functions at the top level of each tab menu. As you can see in this picture, loads types are provided by grouping to enter desired loads data more intuitively. Also, for the selecting design code, we can select them directly from the top level of the design menu. I will show you with the program. When you think about the previous version of Gen, for example, the pushover analysis. If we want to perform pushover analysis, we need this to go to the design and then go to the bottom of the menu and pushover analysis, and then go to the related menu, which is quite long path. So in the new version, if you see the tab, there is the new menu, the pushover. So you can see all the required data icons from here, and this reflects the workflow of the data you need to enter. So let's see with the program. This is the new menu system. And if we see each of the tab, from the view and structure, this order also reflects the modeling order. So you start from the scratch or import certain models, and then you will create some of the nodes or elements and properties boundaries. For the loads, as mentioned previously, the related menus are grouped. And perform analysis, check the results and go to the design and specify the design code you want to apply from this menu. So you don't need to open the additional dialog box for selecting the design code. Also, as mentioned, we provide the dual tree menu. So, for example, if the model is construction stage model, you can see the group tab in the same time, or if you open some of the dialog box, at the same time we can see the worktree so that we can easily select the desired elements from the worktree. So you can see those dual tree at the same time. Let's go back to the presentation. And in this new version, there is another very big change. We can now support 64-bit solver and pre-post processing. 64-bit solver is capable of accessing memories above the 4 GB, which was the limitation in the 32-bit operating system. So huge models can be analyzed, and the solution time will be incredibly faster than the previous version. In this version also we support GPU solver. So if you go to the analysis and then analysis option, we can select the option enable GPU acceleration. GPU solver offers faster solution time composed of a large number of solid elements, especially when the number of degree of freedom is larger than 1 million. We can get the benefit of applying this GPU solver. In order to use the GPU solver, high-performance graphic card is required, and GPU has been applied in the multi-frontal solver of Midas Gen in order to accelerate the calculation of simultaneous equation, which is the highest portion in FEM analysis, like the solid elements. This shows another case study. We compared the analysis time from the previous version and the new version, which supports 64-bit system. So you can see there are big improvements in the analysis speed. Even though the program can support a 64-bit system, there will be no big difference if the model is composed of the small number of beam elements in static analysis. Therefore, I'd like to clarify when we can get a benefit of 64-bit solver. Firstly, if we have the large number of solid or plate elements, just like this model, especially when the model number of elements are larger than 200,000, then analysis speed will be remarkably increased. There is no limitation in the size of the memory the program will use. So if you have a larger size of the memory, then it will increase your analysis time. In some of the Model 5 previous version, we had the out-of-memory error, and we could not solve the analysis, even though the computer capability is very high. But in the new version, if the computer memory is enough, and then such memory error will not occur anymore. Also, we can get more benefit if for the pushover analysis or time history or nonlinear analysis, which requires many steps during the analysis. Because in the new solver, the file in and out process becomes faster. So comparing to the previous 32 bits file storage process, we now have the different process system. So in case of such analysis, we can get more benefit of the analysis time. Let's move to the other feature. We now support the new version of Revit interface. So Revit 2015 interface is now supported. Using Midas link for Revit structure, which is available for free in Midas homepage, the direct data transfer between Midas Gen and Revit is available for the BIM workflow. Midas link for Revit structure enables us to directly transfer Revit model to Gen, and then if there is any change in Gen, we can even deliver the model back to Revit. So round trip is supported, and we can see the data supported for this Revit interface, like for the geometry, and also some of the boundary conditions and loading can be imported in Gen. I would like to show you the video how this Revit interface works. So in the Revit structure model, in the model file, we can see the steel structure, and there are boundary conditions and loadings. Since there is a little time lag with sharing the screen, so I will wait a little time so that you can see the video file. So in the Revit structure model, we can check their section size or boundary conditions and loading input status. After checking the model file, and then we can bring it to Midas Gen. When we bring the data to Midas Gen, we can specify the element size for the plate elements, and the section mapping data can be specified. After that, we can go back to Gen, and we can see the model will be imported. So same geometry and all the data can be imported. I would like to show you real time since the video file has quite large time lag. So I will also show you how we can bring this model to Gen. So this is the Revit structure model. This time it is the concrete structure. This model, if we see the analytical model, we can also see some of the data like the loadings and boundary conditions. In this model, we want to bring it to Midas Gen, so we can send it to Gen. As mentioned, we can specify the element size from this, and if required, in order to match the Revit interface, Revit sections into the Gen identical section. Both program has their certain database, and we can match the same name. But if the name is not identical in both software, in the case, we can also manually specify certain section. This section will be, for example, used in Gen with, for example, the solid rectangle section with their width will be also similarly width, and their height will be similarly height in Gen. By mapping those data, the section geometry will be identically imported to Gen. So once it is defined, then we can send it to Gen. After sending the data in Gen, we can import MGT format file, which is the text format of Midas Gen. So in the new file, I will import the MGT file. So you can see the identical model is now imported into Gen. Mesh size can be adjusted as mentioned previously. So if we want to have more fine or messy, then we can also change the mesh size there. After that, also we can see the data. You can see the sections, thickness, and also boundary conditions enters there. Also the loadings are entered. And we want to update the model. For example, I want to change the thickness of the slab to 300. In that case, we can save back the Revit model file, the MGT format file. So I just saved the MGT file, then go back to Revit structure, and here we can see the update model from Gen. I will specify the text file I just created, and then click update. From this procedure, normally when you bring the model file from Revit to Gen, you will perform the analysis and then you will do the design. After that, you will determine whether this section size will be proper or not. If not, you need to change those section size. So after changing them, you can update this Revit model. When we update the Revit model, we can also see the summary report, what has been changed. So in this model, we can see the thickness has been modified. And let's check the thickness of in the Revit structure model. So for this floor, if I see the thickness, now you can see their thickness changes to 300. So this is the way how we can do the round trip between Gen and Revit structure. Okay, go back to the presentation and let's see the more features what we have in this new version. Similarly to the lab structure, Tekla structure interface is also available, and the version 20 interface is now available with this new version. You can see also the available data format in this table. Just like lab structure, this Tekla interface is also used Midas Gen text format file, and round trip is supported. I would like to move to the next feature, changing plate local axis. In the previous version, when you were dealing with the plate elements with unstructured meshes or cylindrical shape, then you may feel that the rotation of the plate element is a little inconvenient. In the new version, plate local axis for checking the results can be aligned along with global axis or cylindrical axis. Or you can even directly specify the reference vector for the local axis direction of the plate elements. So I will briefly show you how we can do that with the simple test model. In this plate element, if I display the plate local axis, in the triangle element, it was the kind of limitation that we needed. The program always used the same edge for the x-axis. So we could not freely define the local axis of the plate element. But in the new version, for checking the results, you can now see the new feature plate local axis under the results. It means this function will work in the post-processing after performing analysis for checking the result purpose, not for the modeling purpose. So I want to align the plate element, those plate elements, aligned with the global x-axis. So the local x-axis of the plate element will be aligned along with the x-axis of the global coordination. Then once I click apply, now you can see the plate elements local axes are now aligned. And then when we check the results, like the plate forces, these axes will be applied. Or if you are working with the round shape slab, and if you want to check the forces in the cylindrical coordination or for the cylindrical shape of the plate elements, then we can also use the cylindrical coordination in here. For example, I want to specify my x local axis to be the radial direction of the cylindrical axis, and their origin point will be here. In this case, I will zoom the element and then click apply. So you can see x-axis is now aligned to the radial direction, and the y-axis is according to the tangential direction. Even we can specify the reference vector. So for example, I want to specify the reference vector as the 45 degree. In the case, x-axis will be aligned to the 45 degree, you can see here. So in the post-processing, for checking the results, like the plate force or plate stress, and this feature is available for the plane stress and plane strain asymmetric element as well. So we can fully define their local axis. And there is another new improvement which is related to the plate element. Stiffening scale factor for plate element. If you have used the Midas Gen previous version, you may remember the section stiffness scale factor for beam element. With the same concept, we can now apply the scale factor to the plate element, especially if you want to consider the cracks in the slab, for example, then you want to reduce the stiffness of the outer plane direction. In the case, we can specify the scale factor here for the outer plane, and then this stiffness will be applied for the analysis. Also for the unstructured mesh, we have the definition for the axis. So it's basically according to the local axis, but if you define their angle, then this stiffness will be according to the reference direction. If I show you with the program for better understanding, so in this model, we can see the plate stiffness scale factor I have entered only for this element. I will try to redefine it. So let me delete this. And then these are the exactly same model with the same load. And we can compare their deflection after applying the stiffness scale factor. So I want to apply the stiffness scale factor only for this element. We can go to the property scale factor. There is the plate stiffness scale factor. I want to, for example, reduce the stiffness of the bending, auto bending stiffness. And for the direction, if we display the local axis again, their local axis is not aligned, so I cannot use the local axis as it is. It means I need to define the axis for this stiffness scale factor. For that, this is exactly the same as what I just showed you for the plate local axis. So this local x will be according to the x direction, and then I will apply this stiffness scale factor. So click apply. The display is not changed, but the direction, applied direction is according to the what I entered. So after that, if we perform analysis and we can compare the deflection, whether this scale factor has been applied. And for the deflection, we can see the difference after reducing the stiffness, out of plane stiffness, and then we can see the larger deflection in this model. So even for the unstructured meshes, by applying this local axis function, this function will be useful for applying this scale factor. And which type of analysis we can apply this function? We can apply this for the static, linear time history, response spectrum, construction stage, and geometric nonlinear analysis type. Let's move to the next feature. When you use plate elements for mat foundation or slab with wall elements, just like this picture, this option will be very useful. Connectivity between the wall element and meshed plate elements can be automatically considered by checking on this option, auto constraint for wall element connectivity. So if there is any nodes on the same line of the wall elements, program internally enter the linear constraint function, and then they will be rigidly connected and their behavior will be just continued. So under the analysis main control, you can simply check on this option for considering this connectivity. And the other feature is the improvements in the floor load. Floor load is used when we do not model the slab using the plate element, and if we just use the floor diaphragm and apply the loads for the self-weight of the slab or the live load, this floor load is very useful. But this floor load can be applied to the closed area because the floor load should be distributed to the connected elements in that area. There was a limitation previously. We could not apply the floor load if the area is composed of the plate element, just like this model. In this model, walls were modeled using the plate, and then there are beams in the middle. In the case, if we want to apply the floor load, we need this to enter the dummy beam on the top of the plate in order to enter this floor load. But in the new version, we can simply specify the desired region and then floor load will be distributed. Next feature is opening in wall element. Wall element is quite unique and special type of the element in Midas chain. This element is very useful since you do not need to worry about the mesh size, and also the modeling is very simple, just like the beam elements, and it can simulate the shear wall, so it's very useful function. But previously, we could not consider the opening like the door opening or windows opening. But in the new version, now we can do that. How to consider it? If we specify the wall opening, just like this dialog box, and then program will divide the wall element, and then lintel beam will be additionally or automatically entered. And their connectivity will also be considered. After that, if we want to perform design, we can also do the design. For these two walls, we can do wall design. For lintel beam, we can do beam design. So I would like to show you is the program for that. I'd like to show you how we can define the openings. So let me delete the predefined openings. So as you can see, even though we enter the opening, we can simply delete them in the tree menu. Then I want to enter the opening here. So go to the wall opening and specify the dimension and location of the opening. So opening has been generated, as you can see here. And on the top and bottom of the opening, the lintel beam element is created, and these walls are now automatically divided. And if you see here, wall element is composed of just 4 nodes, and there are 2 additional nodes, and you may worry about the connectivity. But if we check on this option again, under the main control data, auto constraint for wall element connectivity, then the nodes which is on the same edge, top and bottom edge of the wall element are restrained internally. So they will behave as one connected element. After that, we can perform the analysis and check the results. So for example, for the deflection, we can see their deflection from this. And if we want to do the design for the walls, we can also do that. For the wall design, we can perform the wall design, and then we can see the results of it. Alright, I'd like to move to the next feature, multi-tower module for story and static wind load definition. When you are dealing with the multi-tower, you may feel it's a little inconvenient for defining the multi-tower, because for definition, even though their jet level is actually same, but you need this to have very small difference so that you can specify different story and then enter the story diaphragm. Even though you enter like that, when you enter the wind load or seismic load, it is also another difficulties, because program cannot use the dimensions of the bottom or the top stories of the certain level of the story. But in the new version, all these problems are now resolved. I would like to show you with the program for that. In the previous version of Gen, you could find the similar feature assign module under the results and then the story tables. However, in the new version, even the pre-processing, we can define the module. So this is the twin tower, and we want to specify each of the tower. By default, when we just automatically define the story will be entered just like this. Different level will be entered like this, but if the level is identical, then just one level will be detected. So I want to go to the story now. Here you can see the new button, Define Module. So if we go to Define Module, we can specify each of the tower, for example, Tower 1. And this tower will start from the B1 since their column is here. So starting from B1, but we do not include the slab level because the tower started from the column of this and up to the roof level. And this roof should be included. And we need to specify the region of it. So we can simply draw the region and then click Add. Once we enter this, we can see Tower 1 is defined, and excepting this tower, other region is always specified as base by default. The right part, I want to specify Tower 2. So starting from B1 again, but no slab level, starting from this column and up to the base loop, including also this slab level. And again, I need to specify the region of it. So click Add. Now, the Tower 2 is also defined. So this part is Tower 1, Tower 2, and these are the base parts. You can see even graphically the region we have defined. And then if we enter for example, the static seismic load, we can see the different graph for the Tower 1 and 2 separately, even in this table. And if we click OK, for each of the tower to the mass center, this static seismic load is entered. Similarly for the wind load, which was using the dimension of the below level. Now we have the different tower. Program can recognize their region. So for each of the tower, we can see program can find out their region and then outside area, and then those story force, shear force, overturning moment will be obtained. And we can also graphically see the wind load is entered to the dimension center. Similarly for the story dialog box, under the wind, we were able to see the floor width and the floor center, dimension center. Those are specified as you can see. Similarly for the seismic load, for each of the tower, we can see that. After performing analysis and checking the results are the same as the previous version when we assign the module. Means we can see the story draft, for example, with each of the towers separately. So when you work with the multi-tower building like this picture, this function will be very useful now. You do not need to differentiate their global level coordination. You can just make as it is and then define their region, and then this tower data like the wind load and seismic load can be automatically calculated. If we see the next feature, in the new version of GEN, warping degree of freedom can now be considered for beam element. In the previous version, in order to verify the warping deformation, we needed to generate plate or solid elements However, in the new version, using the 1D beam element, we can verify the warping effect. How we can consider it? We can see in this section property dialog box, there is additional option, consider warping effect. So warping can be considered by checking on this option. And once we check this option, program will provide the related section properties like the warping constant and the warping functions and also the shear strain due to the twisting moment. By considering this warping effect in 1D beam element, more accurate results can be obtained in case of curved elements or the eccentric loading, or if the section has different location of the centroid and the shear center. In that case, non-uniform torsion will occur, and in this case, warping torsion is required. So this warping effect can be considered. Before I show you the program, I would like to explain a little bit more details on the warping torsion for better understanding of the program results. Torsion can be classified into two, uniform torsion and non-uniform torsion. In case of non-uniform torsion, which occurs when the warping deformation is constrained, in-plane deformation of the flange will occur in addition to the twisting. So in case of uniform torsion, only twisting is there, but in case of non-uniform torsion, there will be in-plane deformation as well as the twisting. So if we firstly see about the same band torsion, which is just a twisting, we know how this torsion can be calculated using the polar moment of inertia and moment of rigidity, and differentiate the twisting angle. We can obtain the same band torsion in case of the circular section. In case of non-circular section, this polar moment of inertia will be replaced by the torsional constant. But for the warping torsion, how we can obtain the warping torsion? This warping, if we think about this torsion, there is the shear force on the top and bottom of the flange, and if we multiply with their height, we can get this torsion, warping torsion. And this shear force is the differentiation of the moment, which is the transverse moment of the top and bottom flange into their longitudinal direction. And how this moment is obtained is from this formula. So finally, we can obtain the warping torsion moment. This part is called as the warping constant. This warping constant is also provided in the program in the section property dialog box. So as a summary, how the torsion is considered that we generally checked in the program as mx value. It is the summation of the same band torsion and the warping torsion. And the same band torsion is the torsional rigidity, and the warping torsion is the resisted by the warping rigidity. And this gamma is the one that the warping constant that I just mentioned. So after checking this, so we know that the torsional moment is the summation of same band torsion and warping torsion, and we will see how they are obtained in the program, how we can consider in the program. In this simple model, this beam element is composed of the 10 divided elements, and their support boundary condition is like this. We restrained 6 degrees of freedom in this left, and we did not restrain the extraction translation in this end. And we have applied the eccentric point load in the middle of the beam element. Then, if we perform firstly, how we can consider the warping? Because of this eccentric moment, this is the ununiform torsion, and this ununiform torsion will be resisted by the same Banach torsion and the warping torsion. So we will be able to see both torsional effects. For considering this warping torsion, first of all, I need to check on this option, consider warping effect. After that, if we see the section properties, we can check the warping constant and the warping functions and the shear strains, which is additionally provided once we consider this option. And in the support, we can even restrain the warping for the support. But I did not restrain the warping in this case. Also, when you work with the P-Mendel release, now you can see the warping effect can be released. After performing analysis, we can also obtain the related results. So first of all, we want to see the beam diagram. So let's check the torsion first. For that, eccentric loading at the center. So as the loading applied to this eccentricity, so we will obtain such torsional moment. So with the negative and the positive direction torsional moment. And we know that this torsion is the summation of the same Banach torsion and warping torsion. So let's see one by one. Firstly, the same Banach torsion. Same Banach torsion, the uniform torsion occurs the largest in both ends, and it is 0 at the center with this eccentric loading applied. And the warping torsion, we did not restrain the warping at both ends, as I mentioned. So when warping is not restrained, and in that case, there will be no warping moment. So only it becomes larger to the point that eccentric loading is entered, and it is largest to the loading position. So if we make summation of this twisting moment and the warping moment, it will be this mx that we checked previously. Other than this, which result is obtained in the program? Let's see. Firstly, for the displacement contour, we can see in the contour for the warping deformation. Since this is the beam element, the warping deformed shape is not supported. So in the deformed shape, there is no warping, but we know the value of the warping deformation, so we can obtain the warping deformation. Also for the beam stress, if we go to the beam stress diagram, you can see 7th DOF, which is the warping. So warping normal stress and warping shear stress for the Y direction and Z direction. For the twisting shear and the warping shear, we can get those. So axial direction and torsion, twisting torsion, and warping torsion, and also combined of all these three. So this warping stress can also be viewed in the program. And if we go to the table, similarly, there is the additional table for the beam stress 7DOF, and we can see their stress. Let's go back to the presentation. So applicable type of element is only beam element. General beam or the tapered beam is applicable. And applicable type of section is all the type of the section we support. We support the database value SRC combined tapered and composite type section. Also the boundary condition as we checked, support and beam Mendel list, and type of analysis, linear static, eigenvalue, response spectrum, and construction stage analysis. Related post-processing is, as we just checked, reactions, displacement, and beam forces, moments, and beam stresses, and all related tables as well. There is one more issue in this warping, which is called bi-moment method. Bi-moment method is approximate method for this torsional analysis for practical purpose. What is bi-moment? Because of that warping, we have this moment, and if we multiply this moment into the height of this section, that is called as bi-moment. So if we know the value of bi-moment, by simply divide df, we can get the mf value, and then using this mf, we can easily find out what is the normal stress and what is the shear stress. So bi-moment is another approximation that also used to some of the practical design standards. And Midas also provides this approximate method as well. Previously, we checked the same Benang torsion and the warping torsion, but bi-moment can also be obtained. And B is the one. Okay, so that was the explanation about the warping. I'd like to move to the next feature, pushover analysis. When you are performing the pushover analysis, for each of the load case, it takes quite a long time depending on your model size and also depending on the steps you are considering. And if you modify some of the data and then you need is to perform all the load case again, otherwise you have to delete the sum of the load case. But in the new version, you can perform the push-over analysis for all the cases, or you can perform only for the selected load cases. So there is the dialog box, as you can see here. So you can check on only the desired load case and then perform it. After you perform, for example, load case A, and then next time if you want to perform load case B only, then the result of A is separately saved and there will be no change whether you perform load case B or C or not. Another improvement in the pushover analysis is related to the wall element. In Midas Gen, we have the wall ID, which is kind of the name of the wall. So if we specify the same wall ID in the divided wall element like this, in the post-processing, the wall diagram, only the summated results can be obtained. However, in the pushover analysis, there was the limitation previous version. The wall hinge was assigned separately to each of the divided element, which is not desired from the engineering point of view. So in the new version, if the straight wall has the same wall ID, we can now assign only one wall hinge and their results will be exactly same as when we do not divide them. There are also many improvements in the inelastic hinges for the time history analysis. I have compared the dialog box in the old version and new version. In the previous version, firstly, you can see the wall is grayed out, means it was not supported at the time. Now it is supported, and we can assign the wall hinge to the wall element. It can considered as the membrane type of the wall or plate type of the wall. Also, the assignment of the inelastic hinge is also changed. We can assign the inelastic hinge previously by the section property. So if we want to specify different inelastic hinge property only for the certain element, we had to divide the section property even though their section sizes are same. But new version, just like the pushover hinge, we can specify inelastic hinge for each of the elements, and it can be assigned also using the tree menu, the works tree. Also, in the previous version, we could not specify the different yield criteria for the I-end and J-end. They should be always identical. But new version, there is the option whether we want to have the asymmetric hinge for I and J end. Then if we select the asymmetric, 2 taps will be valid. This is the other new feature coming in December. We are going to release the minor version once again, including this feature, the star-buttoned section checking. Previously, we have the Eurocode 3 design for the steel structure, but for this star-buttoned section or closely spaced built-up members like the 4 angles, for example, we could not design them in using our automatic design function in Midas Gen, but it will be available in the new version in the December release. And finally, this is the last feature today. addition of RC design module as per the American standard in Design Plus. Design Plus is additional module of Midas Gen, which stands for the unit member design. And also some of the members which is not applicable in Gen, we can design them in Midas Design Plus. In this version, we have the 4 new modules: combined wall, retaining wall, combined footing, and wall footing. So I will show you briefly how we can use those features in Design Plus. The benefit of this Design Plus is we can make the link with Midas Gen, and we can bring the data from Gen. I will open Design Plus. I want to make the link with Midas Gen. And in Midas Gen, one of the limitation is the combined wall design. And we have entered for the Eurocode combined wall in the previous version, but not for the American standard. So for example, for this combined wall, we do not want to design this 4 unit one by one. We want to consider their combined force and then design as the one member. For that, we can bring this member to Design Plus. It is linked with Gen, and I can go to this combined and I can import. So walls are now added in these 2 at the bottom. You can see the walls from this. Even you can zoom in or zoom out. You can display their rebar index or dimension or the rebars, whether you want to display or not, you can select. And we want to design this combined wall. So section size and the member forces are imported to this Design Plus. Also, the reference axis can be specified here for the major and minor direction of the wall. And for each of the wall unit, we can see this wall data means the size of each of the unit. You can see they are highlighted once I click related data, and their rebar status can also be entered just using the table at once easily. And the load combination for each of the wall unit also imported from Gen. And then we can do section check. So with the PM interaction, according to the American standard, we can check this combined wall, and we can also generate the report in the Word format. Not only the Word format report, but also we have the additional tabs at the top of the program, as you can see here: member list, drawing, and quantity. So member list table to see each of the member at once, and also the drawing, which can be saved in the TWG format or TFX format file, and quantity, the bill of material, can be obtained as well. So report is being generated. So we can see the generated report from here. So all the calculations will be shown, and whether it is OK or NG, we can see more details from the Word format report. Even the sections, how it will be shown with the all the rebar and their rebar information, their forces, and finally what is the combined force for all these unit of the elements. And report is very detailed. As you can see, all the equation and the factors used can be seen in the report. So it would be very good for verifying the results. If you are familiar with Midas set, which is the old version of Design Plus, interface is also changed to simple version, which is same as set. So in this simple mode, we can check the section and we can see the results at the same time in this report. So whether we want to use the project mode or simple mode, we can select. I also want to show you the combined footing. Combined footing is also not supported in Midas Gen, but if you need to design this combined footing, you can also use Design Plus. Select two columns and then go to the combined footing and click Import. Once I import it, that is imported here. And even we can specify the dimension as desired and we can verify. As mentioned previously, there are member forces, or in case of the footing, the column forces are imported to Design Plus, so we can verify their results. Similarly, for the wall footing, we can also design wall footing. So select the desired nodes, and in the wall footing, which will be placed at the bottom of the wall, click Import, and here the wall footing is imported. We can verify it again, and whether it is OK or NG, we can see it. If they are not satisfied, we can check it again with different condition. We can see the member forces are imported here, also here. Similarly, the reports in Word format can be obtained. And finally, the retaining wall. Retaining wall can also be designed in this Design Plus. We can specify the dimension of the retaining wall and the soil pressure, and then we can check them. Also, similarly, we can verify with the detailed report. After that, if we want to see all the members in the report, we can also see it in the member list. For example, for the shear wall, member list, we can see all these 4 words in the table format. We can easily change the input data from the table format as well. And we can create the drawing very easily. The cross-section of each of the type will be generated. So for the combined work, for example, we can see the rebar statement and the size of the rebar and dimension of the section can be seen as you can see here. And they can be saved in the AutoCAD DXF format file. Also, the quantity is another interest for the engineer. We can see the bill of material for the rebars and also the concrete and the forms. So this table will also be very useful for as a result of the design. Okay, so that's it for today's new feature content. If you have any question, please use the questions window.